Good afternoon, everyone. In this video, we'll be talking about nested state diagrams. So in the last videos, we have seen what are state diagrams and its basic behavior we have seen. As part of this video, we'll be seeing what are the problems with this sort of flat state diagrams and how we can actually expand these states. Okay, so this would be the agenda for this video. Flat unstructured state diagrams are impractical, especially when you consider large problems. They are highly impractical. Okay, I'll try to give you some examples. Okay, consider an object. Okay, so there is an object, so which is a class. Okay, so there is an object. It has n independent Boolean attributes. Okay, that are actually affecting its control. Okay, say for example, there are n independent Boolean attributes are there, and then their states actually control this sort of object. So that means this object can be in total 2 to the power of n states. And then if you basically draw a single flat diagram to basically show its behavior of complete state diagram, it will have totally 2 to the power of n states. Putting such a state diagram is completely impractical, isn't it? But of course, you can actually partition all the states, okay, in this state diagram, partition all the states, okay, into n independent state diagrams. Each state diagram is actually representing, say for example, one Boolean attribute. It will be yes or no. Okay, it can be an independent state diagram. And then if you basically put these independent state diagrams into this sort of states, you will have only 2 n states into a single diagram. Okay, so basically we need to restructure it somehow. Okay, so that it becomes practical. Okay, unstructured state diagrams are highly impractical for that purpose. Think about a similar situation. Here is a state diagram. There are several states, okay, and the transitions are actually leading to the other states. Now think about if there should be transactions leading from every state to the every other state. You need actually NC2 transitions for n number of states. That would be a big problem. It basically leads to a sort of combinatorial explosion of transitions in flat state diagrams. Okay, so by giving you the example earlier, so the state diagrams are to be reduced. Okay, so I mean we have to restructure them somehow. Okay, so that the number of states or transitions get reduced. Say for example, with this state diagram, it can be reduced to as low as n number of states by using different structural mechanisms, something like subdiagrams, etc. Okay, so these are the problems with these sort of flat state diagrams and what can be done. Let us see what can be done. Okay, so one of the solutions is to basically expanding the states. Okay, so one way to organize a model is by having a high level diagram with sub-diagrams expanding certain states. Okay, so that is about expanding the states. Okay, this is more or less like a macro substitution. Say for example, in your operation, there will be a macro, and the macro will have its own implementation. In your program, the macro will be exactly replaced there. The idea of this expanding the states is also the same. So there will be a state diagram. One of the state, okay, so you will actually represent in the original diagram. At that particular state, you will have a complete sub-state diagram. Okay, and which will be actually substituted here. And this sub-state diagram is actually called sub-machine. A sub-machine is a state diagram that may be actually invoked as part of another state diagram. Let me show you the example that actually makes it clear for you. See, here is the state machine for a vending machine. So the vending machine will be in ideal state usually. Okay, that's pretty clear. And then say for example, you are inserting the coins. We already have seen about the activities. Okay, so basically when the event basically is coins in is happening, so that means you are putting in the coins. Okay, so then the activity that is happening is you are actually setting the balance. Okay, so with that particular event and then that particular activity set balance. Okay, so you are actually moving towards this collecting money state. Okay, so once you are in this collecting money state, there can be other events coming in. So that means you are putting more coins. So coins in. Okay, so and then you are putting more coins in. So this is again like basically you are adding to the balance. So that is the activity that is happening there. Okay. So originally like you set the balance for the activity for that event here, and then like here, so we have already seen like so there can be different types of activities. Okay. So in this case like so we are seeing this sort of event. Okay. So the points in is the event, and then like this is the activity which is happening, and then like you are still in the same state. Okay. So collecting money state is there. Okay. And then like say for example after certain time, like if you feel like you have enough money, okay, you can select the item. Okay, so that is the event which is happening. So selecting item is the event which is happening. So then you are moving to a state where like you are basically doing the do activity. So test item and compute change. Okay, test item and then like compute change is this sort of activity that is happening in this particular state. See this state don't even have the name. See, the point is like, say for example, you cannot have names for all the states. Of course, it would be ideal to put names for each and every state, but it is not practical always to put it. So in this case, like it is an activity which has this sort of do activity. So do, and it is actually testing the item and it is completing the thing. Okay. And then like while you are actually testing the item, whatever is he has selected it, if there is a guard condition, like say for example, if that particular item is empty, he will actually move back to this sort of collecting money state. Okay, so more points can be put in, or at that particular state, like the user basically can cancel the transaction. In that case, like you can actually refund the points, whatever he has entered. With that one, like you will actually move towards this ideal case. Okay. Of course, like say for example, if everything is okay, so and then like if the change is less than 0, okay, so basically that means like you don't have enough money to be money entered, so that means like you will move back to the collecting money and then like you ask the person to add more money, okay, because the item is cost more, okay, so you have to move back to the collecting money state. Now interestingly, once you have calculated this one, if the change is greater than 0, so that means like you have to return some change, you go to a state where like you will make the change. Okay, it has to basically collect different points for that one. Okay, so the machine will do that. So that's again like a do activity in that particular state. Okay, you basically make the change, and then like you basically dispense that item. Okay, so earlier like even from this state, like if the change is 0 also, like you will basically come to the dispense item state. You basically, that means like you give the item to that person. So okay, so dispense state is that particular state, okay, where like you are returning the item to the user and you will move back to the ideal state. But the interesting thing is the dispense state here is the submachine. So it has its own state diagram for that. Okay, so the dispense item is itself a state diagram. What it does is like it has the start event. So basically what it will do is like it will go to a state where like it is doing a certain do activity, move arm to the correct row. Okay, so it will move the arm to the correct row. Okay, once the arm is ready, so that means like it has moved to that particular place, then it will do the next activity of do arm to the correct column. Okay, say for example, wherever is that particular item, it has to move that particular row and then like it has to move the arm, so the robotic arm which actually puts that item. So it has to basically move to that particular place in the vending machine. So once both the arms are ready, okay, both arms are ready, okay. So that means like you basically do the next step where like you do the do activity, do push item off the shelf. Okay, so that means like you are moving to that particular row, you are moving to that particular column, and then like you will take that item and you will basically push the item off the shelf. Okay, say for example something like this one. That actually makes it fall into that place where like you can actually take. So that means like that actually generates this sort of pushed event. Okay, the item is actually pushed out. That actually finalizes this dispense state. You see, actually like the dispense is the state now which is a submachine. So that means like it itself is a state transition state diagram. Okay, states and transitions. State diagram here. So the UML representation is like say for example this is the dispense is the state name, and with a column the submachine dispense item. So this is how like you will actually represent the state name whenever like that is one of the particular state is a submachine. Okay. So once that item is actually pushed, you will move back to the init state. Okay. So that's about having this sort of one approach of having this sort of submissions for that particular nested state diagram. So regarding the reference is concerned, now we are in chapter 6 of this object-oriented modeling and design with UML. Okay. Michael Blaha and James Wimborne. Thank you very much for your attention.